Alright, good everyone. Welcome back to another wonderful section of this lovely Trig class. Today, we are just going to be looking at summary of course, calculus. So, we're going to be solving questions under calculus, questions you will likely see maybe in example publications, some example questions, and so on. So please don't skip any part of this video. I will beg you, don't skip any part, because this class is just all about solving questions. Just like you want to check how far you have gone in this topic. But then to be solving questions upon questions upon questions upon questions. You want to solve questions in mathematics, but not only about practicing. You practice more questions. So that's what I want to do here today now. I want to do practical practice. So we want to show you how to actually practice mathematics questions. So we want to do the practical aspect of it. When we say practice. We want to solve a lot of questions here. We'll be solving questions. So what you have to do for me, you have to avoid distraction. You know that I want to subscribe to the channel, try to subscribe. It's very, very important as well. But one of the major things here is try your best to watch this video from the beginning to the end. Don't skip any part of the video. Don't skip any part. Watch it from the first second to the last minute of the video. Just keep on watching. Keep on watching. Try and get what I'm trying to explain. And you can even be jotting things down. It's very, very important. Don't distract yourself by any means. Don't distract yourself by any means. So please, please, watch it. Even though something like, for example, now, if there is anything here you don't understand, you are free to come back again, watch the video over and over again. You can also drop the question by comment section if you have watched the video over and over again. Please don't have to skip it. So please, don't skip any part of this video. So the first topic I'll be starting from now. I'm starting from limit of a function. Limit of a function. Now, from the first video we did, you know you have not watched that video, you can go and watch the video now. We have done a very good video on that limit. When we said the limit of a function is the value the function approach if the input or the variable in that function approaches a particular value. So the limit of the function can either exist or you fail to what? To exist. Exist if both sided limit exist, and you fail if one sided limit fail to exist. So we are not going to look at those stuff, but we are going to look at how to evaluate the limit. Already mentioned methods of evaluating limit. We said we have direct substitution method, factorization method, rationalization method, NO2 method, Tumb'S rule, and the rest. Substitution method, expansion, and the rest. So today we are just going to be solving. We are just doing something like summary about the topic. So we will be solving questions, how to actually go through questions under this topic. Now, let's say we have a question. Now, limit questions are always in the form either we write LIM or we just tell limits of the function, let's say x plus 3 over x plus 1 as x approaches 0. Limit of limiting the function x plus 3 over x plus 1 as x approaches what? 0. So remember, we have done a topic limit before, and this is just something like revision, summary. Just we want to summarize the whole topic now so that you will see it. That's how we wrote. So let's go with this. So let's limit this function at x approaches 0. Let's see what we're going to have now. Remember, the first thing is to check if I place this x at 0, at x equals 0. Will the function be defined or undefined? Now, the function will be undefined if you have something like this, 0 over 0, or a number over 0, or you may not even have, you cannot have infinity over infinity. It's not possible. So this is not possible, this is not possible, this is not possible. So mainly, you ensure that the denominator is not 0. That's the first thing. So let's check. If we put this x at 0, the denominator will be 0. Let's check. X will be 0, 3, 0. Plus 1, we have 3 over 1 is equal to 3. So, therefore, the limit of function and x approaches 0, we are going to have 3. Why? Because the denominator is not 0, so we are going to go. So that is the first method. If you have any limit problem, the first method you just use just to apply direct substitution. That means substitute the value of x, the value of the variable here, into what way you are saying in the function. Let's say we have like this limit. Another question now. Let's say we have the question limit. Limiting value h approaches 0 of h squared plus ah plus a squared all over h squared minus a squared. Over h squared minus what? Minus a squared. So let's go and do that. Remember the first thing you do is to place 0 anywhere you are seeing the equation of put 0 there. We will have 0 square. Anywhere ch put 0, we will have 0 square plus a times 0 plus a square all over 0 square minus a square. Now give us 0, 0, 0, and we have a square over minus a square. Now this here 1, a 1. 1 minus 1 equals minus 1. See? Why? Because the denominator is not 0. The denominator is not what? It's not 0. So what about we are having something of this nature? Should I give you something? Now, what about if this question is not in this form? This is what I was talking about. This is what I'm talking about. See, look at it. This class is just something like solving questions. We just be solving questions. We understand how to actually run this limit. So let's say we are going to be solving questions or questions or questions again. Questions or questions. Then we have limiting the function, the same function, h squared plus ah plus a squared all over h squared minus a squared at h that approaches a, not 0 again. If h approaches the constant a, what is going to be the value of this limit? Let's go. First thing, anywhere see h, you put a, you have a squared plus a times a plus a squared all over a squared minus a squared. So you're going to have a squared plus a squared plus a times 3a squared over 0. A squared minus a squared is 0. Since the denominator is 0, bad. So we don't work. Why? The denominator is 0. So this method will not work. So now using any other simple method can be factorization method, rationalization method, any method you like. But we cannot rationalize one because there's no sort there. But me, I always love all this, everything I'll be doing here today, I'll be using just 3 methods. Direct substitution, L2 rule, and Tumb'S rule. I will not use any other one. Let's go see what I'm going to have. So using L2 rule, using L2 rule. L2 rule, remember, we have done L2 rule before. We said L2 rule is not if the L2 methods fail to solve the problem or make the function to be undefined. What you do, you differentiate the numerator and the denominator with respect to this variable here. Not this other one, the first one here, which is h. So we're going to differentiate both sides with respect to h now to see what we're going to have. So differentiate h squared with respect to h, we're going to have 2h. Go back to differentiation. If you don't know how to differentiate, please go back to differentiation. We have done differentiation of polynomial, trig, exponential, logarithmic, everything is inside this channel. Go and look at them. So differentiate h squared, we're going to have 2 times h, 2 minus 1, we're going to have 2h. Then plus, differentiate ah, the answer is going to be a. Why? Because differentiate h with respect to h will be 1. 1 times a is a. Remember I told you, differentiate something, let's say x with respect to x, that's how we 1. Differentiate p with respect to p, that's how we 1. That's how it is. So, plus, differentiate this a squared, that's how be 0. Why? Because there is no h in this place. That will become 0. Differentiate this h, we will have 2h. This h squared, we will have 2 times h, 2 minus 1. Differentiate this one, there is no h here. That's how it becomes 0. The next thing, anywhere you see h now, 2a again. After your differentiation, let's do it. Now we are going to have 2 times a plus a over 2 times a. That 0, 0 will go. So we're going to have 2h here, 2a here, 2a here. We're going to have 2 times that is 2a plus a over 2a. And it was 3a over 2a. That's 3a over what? Over 2a. The next thing, a can cancel a, then we'll be having 3 over 2 answer. 3 over 2 answer. Remember, differentiate one, we have 2h. We only differentiate that because it does not give us 0. And if it does not give 0, that becomes the answer. So, differentiate one, we have 2h. This one give us a, this one give us 0 because there's no a here. This one give us 2h. This one give us 0 because there's no h here. So, we have this 2a here. 2 times a plus a, that is 3a. Divided by 2a. Then you're going to have a cancel b, you're going to have 3 over 2. Now, let's do another question. Let's do another question. Let's have limit x approaches 0 of cos x over let's just say of cos x. Limit x approaches 0 of cos x. Let's see what we're going to have. We're going to have something like this. Anywhere see x equals 0, you have cos 0. And what's cos 0? 1. Answer. That's all. That gives us the answer. So let's look at this one. Look at this. Limiting x approaches 0 of sin x over x. Let's see what we're going to do that. Anyway, see x equals 0 first. We have sin 0 over 0. That gives us 0 over 0. Bad. But don't do this one 0. It's not possible. Don't do this one 0. That's not possible. Now let's use L of 2 method now. Using L of 2 method, though this will not work. So let's use L of 2 method now. Now we're going to have limit x approaches 0. Now differentiate this one. Differentiate sin x. Remember the trig function we did. Differentiate sin x. We're going to have cos x. Differentiate x. We're going to have 1. Differentiate sin x. We have cos x. Differentiate x. We're going to have 1. Differentiate x relative to x. 1. Sin x relative to x cos x. So anyway, say it's not good, you get cos 0 over 1. It was 1 and it was 1. So actually, the answer is equal to 1. So let's look at another question now. Let's see what we're going to have. Look at this question. We have limiting x equals 0 of sin 7x over 3x. Look at this question now. And remember, look at it. The first thing is to analyze. There's no need of people writing the question out again or checking. Now, I'll just put 0 in any way you are seeing this and check if the denominator will be 0. Let's check. If I put 0 here now, 3 times 0 will be 0, the denominator will be 0. So there's no need of substituting directly again. Okay, it's very clear. It's not like you just differentiate first. No. The first thing, everybody says, don't put 0 there. Check if the denominator will be 0. If the denominator is 0, means there's no need of solving that differentiation because it will be undefined. Next you have to do is to differentiate both sides from L of 2 root. So we are going to have something like this. Use 0. Differentiate this side 7x. Remember from trig function we did. If I want to differentiate side 7x, first we are going to differentiate this 7x. Differentiate 7x, that's how we becomes 7. Write it down. That's how it becomes 7. So we write that down. Then the next thing, differentiate sine. We will have cos. The next thing, you write down differentiate 7x, you have 7. Differentiate sine, you have cos. And what's going to be? This one side, the same thing, which is 7x. Let's repeat that 7x back. So you don't repeat this from back after you have 2. Differentiate this one first, you have this. Differentiate this one, you have this. Then repeat it from back. That's all. Now, differentiating this 3x, you have 3 from the polynomial function. Let's take a CS now. Since you have differentiated once, 2x, anyway, CS equals 0. You have 7 cos 7 times 0 over 3. Now give us 7 cos 0 and 3. Now give us 7 times cos 0 is 1 and 3. That will give us something 7 over 3 answer. So let's have limiting x approaches 0 of sin 22x over sin 10x. Of sin 22x over sin 10x. So let's check. If we put x directly, if we put 0 directly, if the answer is going to be, is it not going to be 0? So if I put 0 here now, 0 times 10 can give us 0. Sine 0 will give us 0. So we don't give 0, we put 0 directly. There's only not put 0 here. Let's using number 2, differentiating both sides. So differentiate the upper side first. Differentiate the upper side. Differentiate sine 22x. Differentiate this 22x. You have 22. Differentiate sine. You have cos. Then you put this 22x back 22x. Over. What about sine 10x? Differentiate this 10x first. Remember what we did before. How we was saying. Differentiate sine. You have cos. Then you put this 10x back 10x. So after everything, then we are going to place anywhere Cx equals 0. Put 0 anywhere Cx equals 22. Cos 22 times 0 over 10 cos 10 times 0. That's going to give us 22 cos. That's 0 over 10 cos 0. That's going to give us 22 times 1 over 10 times 1. Because 0 is 1. 0 will give us 1. So we have 22 over 10. So we have 2 over 10 or 2.2 or 2.2. So we have the next is we have limiting s equal to 0 or sine 5x over 4x. Now there's a shortcut for this. Let me teach you a very good shortcut now that you can use to cut this question short. Now let's say number one thing you know about this shortcut is that you can see the shortcut will work for this and this. Number one is that the times here must be sine, must not be cos. Take note, must not be cos terms, must be sine terms. Number two, this x must be just a single term, which is 7x, 8x, ax. Must be form of ax. For example, that it must be something like this, form of this, sine ax. And it must be something, just a single term, not x plus something or minus something. No. It should not be plus or minus here at all. And that's the first thing. Just leave out first. Then next, the next thing is the x in the terms, or the x in the terms must have a degree that is 1. That is, it must not be s squared or s cubed. It must be s power 1. S power 1 is s power 1. That is the rule. Well, first root will be sine, second root will be the form of sine ax all over, let's say sine bx and bx. That's how it's going to become. So that you have, okay, let me just write this somewhere. If I have, let me write it here. If I have limiting x approaches 0 of sine ax all over sine bx, or limiting x approaches 0 of sine ax all over bx. You can see it now. I already told you it must be sine terms. And tan will also work. Tan will also work. Tan will also work out. Yeah, use tan will also work. Tan and sine will work here. Now, we must sine or tan, and the power of x must be 1. And these sides must be a single term, must be something like ax, only form of ax, not s plus something. Not 2 terms, just 1 term should be here. 1 term should be here. The angle here must be 1 term, not plus, it must not be plus. So, if you have it that way, the answer is going to be the coefficient of this x divided by the coefficient of this x. And that's also the coefficient of this x divided by the coefficient of this x. That's going to be the answer. So, for this one now, the answer is going to be the coefficient of this x divided by the coefficient of this x. Answer. So, if I have the limiting, check one bit before. That's how it was. Coefficient of x, coefficient of x, 7 over 3. Remember this one, 2 over 10. That's it. 2 over 10. Now let's look around. Limiting x equal to 0 of sine 7x all over sine 5x. Answer will be 7 over 5. Answer. Now what if I have limiting x equal to 0 of sine 3x all over 7x? Answer because what? I'll tell you the answer. Chance you can write the answer down if I write it. Alright. Okay, the answer is going to be 3 over 7. That's going to be the answer. Now, again, it must be x approaches 0. And that's the last thing. It must be x approaches 0. From the side, must be a single term here, just here, so bx or bx, and the x of this one, and it must be x approaches 0, not a number less than or greater than 0. take note of that. See how if your operator is S and 0 for this shortcut to work with this shortcut we are doing. Now let's have one more. Limit x approach 0 of sine 4x over sine 6x. Okay, I'll write this. Let's see. All right, check. All right, that's all. The answer is going to be, okay, let's say 4 versus or 2 over 3. Because 2 here will give us 2. 2 here will give us 3. Or 2 over 3. Now, these two are called equivalent fractions. Equivalent fractions. So you can just divide by 2. You have 2. Divide by 2, you have 3. Now, let's also see we have one like this. Let's have one like this. Limiting x approaches 0 of sine 10x all over sine 9x. What is going to be the answer? 10 over 9. So let's have one more. Limiting, and it should not be cos, so take note to it should not be cos. It should not be cos, so take note to limiting x approaches 0 of sine 3x all over, let's say, all over 2x. The answer is going to be what? When you answer that, so it will be 3 over 2 answer. So, that's how it is. So, B, function of this over this, function of this over this, function of this over this, function of this over this. So, now let's add more questions now. More questions. We have a lot of questions to solve for this limit. We will solve a lot of questions. Let's add more questions. Alright, let's look at these questions. We have questions on the board. So, these questions are just simple questions that easily like solve. Generally understand the rules of the calculus. Remember, I told you guys that also uses the principle of differentiation. So we have done a lot under differentiation. So if you know you have not looked at our rules of differentiating some important variables, ensure you do that. We have done product rule, quotient, and the rest. We have done a lot of them. Chain rule, implicit function, differentiation, and the rest. So please try and look at them. Very, very important. Very, very important. So let's start it on. First thing, let's check. Now, they say S approaches A of this function. Anyway, see the level of to see if you don't give us 0. So if you put A here, we have A power 3 minus A power 3, that will be 0. So you don't know 0. So that will not work. That will not work at all. Since if S is A here, it will not work. So what are we going to do? The thing will be undefined here. So we are going to differentiate both sides now. We will differentiate both sides. So let's differentiate this one. We will have the limit. S approaches A. So differentiating this one, S where was 2x minus differentiating A plus 1x. See, look what we are doing. We differentiate only this x out. That's the way active term here. This one is a constant number, but there's no x here. But since S is in this place attached to this, it's just like this one is like A S. Remember I differentiate A S, that becomes what? A. This S is only A will be left, so only one will be left now. That's right, this one means, this bracket means this one is just one thing. This one is, the treat it as just a whole, just one. So if you differentiate A, this one becomes A. Remember that. So if you differentiate this one, we're going to have A plus 1, the S group, the S is 1 times this. So this one is 1 up to 0, let's go to the S here. Differentiate this S out, then leave this one, let's want this. The shape A is no S this place, not equal 0. The shape is equal to 3S, 3 minus 1 equals 2. The shape is 1, there's no S here. Then S is equal 0. So next, anywhere you see X, you put A, you have 2 times A. Now, minus times A, how will be minus A? You are going to put minus now. Minus times plus, now minus 1 over 3A is equal to 2. That's going to give us 2A, okay, that's going to be 2A minus A minus 1 over 3A squared. So 2A minus A, that gives us A, that is 2A minus 1 times 1A. So just like 2 minus 1, that is 1, now be 1, that's pick one of the A, that is 1. So just 2A minus A, that is 2x minus x, that will be 1x. So it's 2A minus A now, 1A minus A, that is minus 1. This one right here over 3A squared. you got the answer to that. Please take note of that. Next is a very short thing, very simple thing. So you know how to differentiate very well. Before 30 seconds you are through with the question. Just like this. Just like this. The first thing, anywhere says put 2. Put 2 here. 2 minus 2, 0. The result will be 0. Check. The result will be 0. I put 2 here. 2 minus 2, 0. So it will not work that way. The actual result will not work. So what are we going to do? We are going to differentiate both sides. We will differentiate both sides by L2. Differentiate this. You have differentiate up and down. Up and down. You have 2 s there. Differentiate 3 s, you have 3. Differentiate this. No s there. 0. Differentiate this one and becomes 1. Differentiate s related to s is 1. Differentiate 2. There's no s in this place and 0. No s in this side. So give us 0. So give us 1. So give us 0. So give us 3. Differentiate really s and differentiate 1 give us 2s. So you can see s equal to 2 times 2 minus 3 over 1. So 2 times 2 is what? 4 minus 3. Divided by 1 is the same as 1. So 4 minus 3 gives us 1. So that's what? Now what about this? Let's look at this. So we're going to have. Now, anyway says equal 0 will be 0 squared minus 0. Check this. Check this. That is not just the major thing. If you don't know, give you 0. The direction will not work. So 0 squared minus 0, that's 0 already. So it will not work. So what am I going to do here? What am I going to do here? I'm going to use either L2 or factorization or any other thing. Now I would have loved to use L2 here. But since factorization method will be shorter, I will use factorization method here. I will use factorization method. So look at it. Don't use L2 to differentiate this. We have x sin x. We use product for this. We use a normal polynomial function decision for this. But you see it very nice. But since we can factor out s in this, look at it, s is common. And this s will cancel that. So like this x sin x over, look at x is common. Bring out 1x. How many s will be here? Just 1. Bring out this x, only 1 will be here. So this one will cancel this. So the question will be reduced to this s equal to 0 of just sin x over x minus 1. So you can see s now to 0. So we are going to have sin 0 over 0 minus 1. That will be 0 over minus 1. That's 0. That is 1. Okay, that's 0. 0 divided by any number is equal to 0. 0 divided by the number is 0. Take note of that. Also take note of this. Okay, that's still going. So remember something. Now, let's say number 3b. Remember something. Limiting x approaches 0 of sin 4x all over 5x. What will this one becomes? Okay, I'm not forgetting that too. What is the answer to that? The answer is going to be 4 over 5. 4 over 5. 4 over 5. Answer. Please take note of that too. It's very, very important. So we are just feasting on calculus today. We are just eating and eating questions. We eat and eat until we full. Questions are still coming. You just question, answer, question. After this class one, you will be saturated in limited calculus. So look at this. Look at this. Anyway, say everyone put 0. Put 0 here. Put 0 in this here. Sin 0 is 0. 0 will not become 0. So that will not work. The next thing, can we factorize anything? No. We cannot factorize anything. So the next thing, let's differentiate both sides. Limit x equal to 0. Differentiate x sin x exponential x. Now, we have two functions here, x and exponential x multiply each other. So, we're going to differentiate two functions that is joined together, in which both of them are active. They are not compositely combined, or they are not function of each other. They are function of a function. They are just acting as a whole. They are not acting so that they can act alone. They are just like multiplication of two functions. S exponential x equals s exponential x. So I'm going to use product 2 to differentiate that. So using product 2 for this, remember for product 2, you know we have not watched our differentiation techniques. Please go and watch it. It's very, very important. So if you want to differentiate one, you have to do it. If you want to differentiate this first one, that equals 1, then you leave the second one, the first two. If you differentiate this first one, leave this one, you have this. Then you will now add D2, some of the addition will must, will be plus. Then you go back to the same question. you leave this first one now, and you already did before, and you have to achieve the second one, you have exponential x. Remember, if you rotate exponential x, you come exponential x to your change. So remember, you rotate this first one, you have one, you leave the second one, plus on the plus, that's on the rule. You go back to the same first one, leave this first one now, you rotate the second one, you make it. So if you rotate exponential x, that's how you get as exponential x. Let's do that. But rotate this side, you have cos x. So next, anyway, see x, who's 0? Because the level was simplified, that's your graph exponential x plus x exponential x over cos x. So you have exponential 0 plus 0 exponential 0 over cos 0. So exponential 0 will give us 1, 0 times 1 will give us 0, or 0 will give us 1. So this here, 1 plus 0, 1, better than 1, cos 1. The other last question is actually 1. So please take note of that. It's very, very important. So let's have more questions. More questions. We're going to solve questions in this class, and you yourself, you will say, yes, I have got something today. So just we're going to solve more questions. Alright, let's have more questions. Now, the first question we have here is the one and the rest. Now, how do you resolve this mystery? The limiting the function at s averages 1. Remember the first thing we do, as that is averaging 1 so anyway, see a jump 1 minus 1 is 0, jump becomes 0, so there's nothing you can do there. Next thing, you have to solve it out. Let's use the other two methods now. Multiple sides, so we're going to have limiting x averages 1, and measure 10x for x, not if you measure 10x, you measure 100x, that becomes 100. You know, 100 per x, this one becomes exponential function. Now, I've sent a video, I hope I have uploaded a video under that exponential function. I'm going to say, differentiate this 100 per x, I'm going to have the question of x, 100 per x, log of the base to base e, or in of the base. Then, minus 16. For this one, I'm going to have 10 raised power 2x. The set is supposed to be log of the base to base e. But what I'm going to do here is you have to multiply. You have to multiply. You have to differentiate, or you have to multiply this log of the base to base e by the differential function of this power. That is the only difference between this and this. Remember, this power is just x. But if this one is not x squared or 3x or x plus something, or it's not just x again, what you do, write out the answer like this, then you differentiate the power and use to multiply this log. That's what you're going to do. So you're going to differentiate this 2s, and differentiate 2s, you have to multiply the log. That's what you're going to do here. You think of that, it's very, very, very important. Very, very, very important. The next thing I'm going to do here, we're going to have over differentiate x, you have 1, differentiate 1, 0. So let's see. Let me see what we can do here. Let's see what we can do here. Then, remember we can move this place, move to this place. These two can move up to this side. That two can move up to this side. So, we are limiting x averages 1 of 100 raised to power 1 log 100 to base e minus x power 2s. Now 10 power 2 will be 10 power 2. Yeah? Let's say here 10 power 2 like this. Raised power x. Remember 2 times x give us 2. 10 power 2 is 100. Raised power x. Then times log. If this now move to this place, this will move to this place from square here. We have 100 to the over 1. So this minus this 0. Look at it. This minus this 0. 0. So that is 100 log 100. 100 is per x. 100 is per x log 100 minus 100 is per x log 100. It was 0. That was 0. You have 0, 0. So that will give us 0. You can do it here. I will do it here. Just say 10 is per 2. That is 100. 100 is per x minus 100 is per x. 0. 0 per this. So the answer becomes 0. The answer is 0. So please take note of that. So let's look at this. Look at this. Limiting x limiting phi approaches 0, limiting the function as phi approaches 0 can phi over phi. So if you put 0 here directly, the answer is going to be undefined. So what you have to do, you have to differentiate both sides. Now, differentiating phi. Differentiating term phi related to phi, we're going to have sec squared. Remember, differentiate term, we're going to have sec squared. We have sec squared phi. Now, differentiating phi related to phi, since that the same thing, then that becomes 1. So the next thing, when you see phi equals 0, we have sec squared 0 over 1. And sec squared 0 is 1. Just like cos inverse, 1 over cos 0 is 1 over 1. That gives 1 over 1 is 1. Remember, sec square 0 is 1. Don't read it out to. Let's do this next one. Limiting 1 minus exponential phi divided by phi, and phi equals 0. Also put 0 here, that is going to be undefined. So next you have to differentiate both sides. Phi approaches 0. Let's differentiate both sides now. So these are very simple. Differentiate square 0 divided by 1. And we call 1. Because square 0 is 1. Square 0 is 1. Or 1 over. Sec means 1 over cos. Sec square means 1 over cos square. 1 over cos square 0. Cos square 0 is equal to 1 over 1 minus 1. So let's say differentiating 1 0. Differentiating the exponential phi, the to phi will remain the same. Cos phi and phi are the same thing. Differentiating the exponential x remains the same thing. Differentiate phi to phi 1. Differentiate sum to that same thing, that's not 1. Equal to. The next thing let's see phi equals 0 minus exponential 0 over 1. But exponential 0 is 1. Because minus 1 over 1, equals minus 1 side. That's minus 1. So it is very simple thing. The only thing we need to learn, we must want to differentiate very well. That's the first thing. We must want to differentiate very well. And I've done a lot of topics on that differentiation. I've done everything here now, on differentiation. I've done differential function. That's why, in case you are finding it difficult to differentiate some of these functions now, go back to differentiation, study it well, and come back to this revision class again. Then you will grab more. So let's try this. Anyway, say let's try for 1. So the 1 here, we're going to have 1 square give us 1. Look at this. 1 square give us 1. And 1 times 6 give us 6. Plus 1 again. 7. 7 minus 7 0. So if you place 1 anywhere as in S, the denominator is going to give us 0. After the denominator is giving us 0, there's nothing we can do. So we have to differentiate both sides. So differentiating both sides from the two methods. And differentiating both sides now. Now let's differentiate sine pi s squared. How do we differentiate that one? So the first thing we're going to do, we're going to differentiate this front. Sine pi s squared. Related to x. So differentiate pi s squared related to x. What are we going differentiating this x squared give us 2x. Now 2x times pi. See look at what it does do. We differentiate only this x squared. Differentiate x squared. Remember if you differentiate x squared, that's not what? The x squared over the x, that's not become 2x. That's what we have. Then we not use this word to multiply this pi that is here. We're going to differentiate everything. We want to differentiate it, but don't differentiate pi. Differentiate pi will be 0. So don't differentiate pi. Don't differentiate only the s and leave the pi alone. The other going to get from the s is to multiply the pi. That becomes the final answer. So differentiating this s will give us 2x. 2x times pi will give us 2 pi x. That's what we have. Just differentiating only the s out. The next is differentiate sine. We will have cos. We will have cos. Then, after you have differentiated this side, remember you repeat the form back from 3 portions. Pi s squared. You spend the same. Differentiating this one, you have the differentiating this, you have the repeat this form back. Differentiating this 6s, we're going to have 12x. 80s, you have 1. 87 is 0. We now have this at all. Differentiating this one, 2 times 6, 12 minus 1s, 12x. Differentiating this one, we're going to have x equals 1. Differentiating 7 is 0. The next thing I see is put 1. Put 1, this one, let's see. We have 2 pi times 1 cos pi times y squared over 12 times 1 plus 1. That give us 2 pi times 1, that is this, okay? And we will 2 pi cos. This one times this. Is cos 5 over 13 over 13. And cos pi means cos 180. In terms of angle, when this line is 3.142, this one at the back of the trig function will be 3.142. When it's acting alone, you call it 3.142. But when it is acting, that is the value. When it's acting as an angle to a trig function, it becomes 180 degree. 180 degree will be equal to pi in radian. So I'm going to treat it as a degree angle, which is 180 degree. And cos 180 is minus 1. Minus 1 times 2 pi. Or cos pi is also treated as minus 1. Take note. So in radian, cos pi is minus 1. In degree, cos 180 is minus 1. 180 degree and pi is the same thing. 180 degrees is equal to pi radian. We have degree angle, we have radian. Let's not go there. So just cos pi is minus 1. Minus 1 times 2 pi, and it was minus 2 pi over 13. And from the final answer, minus 2 pi over 13. Theoretical thing. Oh, you have to settle down. Not to differentiate very quickly. That's the first thing. Next. Now, this question is s approaches 0. Take note. S approaches 0, not s approaches 4. So if this s approaches 0, what is going to be the value of this function? First, you just don't know this or put 0 here. 0 to power 4 is what? 0. The result is 0. So we must differentiate. We must what? Differentiate. So limiting s approaches 0. Differentiating 4. That is cos 4x. That is cos minus. Remember? Okay. Let me not go straight. Let me see explain. Because those are not very something like I don't let me speak. So I'm just going to come here and explain. Now let's change this. Let's change this cos 4. Change 4s first. We will have 4. We change 4s. We have 4. We change cos. We will have minus sign. That's why I'm mentioning minus before. I want to explain it here. Then you repeat the front back. This one we will have 4. This is for trig function. Negative for that one. Now what about polynomials? Let's see polynomial. Use the power of mechanical coefficient, it is 4 times x, you move up with without t. That's your polynomial. That's why for three functions. Must also achieve polynomial, trig, exponential, logarithmic, hyperbolic. So you can move well in the calculus, differentiation calculus actually. The next, you put 0 here, it will be 0. So as far as there is s in the denominator, it will keep on giving you 0. So what I'm going to do, we'll keep on differentiating both sides until there will not be s in the denominator again. Because in this part now, denominator is just 1 10. As far as there is s here, we give not 0. So let's differentiate again. Now we're limiting s equal to 0. Differentiating this, we will have minus 4 is already there, minus 4 times, okay, differentiate. But this one is already there, don't forget about this one as well, it's very fast. But then differentiate sine 4x, that's going to give us 4 plus 4x divided by, this one, where is the CS there. The CS there. So differentiate it again. Minus 1 times 1 was 16. Now the differentiate cos 4x, that was minus 4 sine 4x. Remember, you don't give us this one. This one times this, that's going to give us this. Now the differentiate cos 4x, that gives us, remember, the differentiate cos 4 is what? We're having minus 4 sine 4x. That was minus, the differentiate cos 4x, and we have minus 4 sine 4x. Then over, differentiate 12x, that was 24x. That's what we have. 24x. 24x. That's going to differentiate again. That's going to differentiate again because the CS is the denominator. We're going to differentiate the 2x is the denominator again. Since if the s is the denominator, the denominator will give us 0. That's why we are differentiating this into. We're doing this stuff over and right because if there is s in the denominator will give us 0. We want to ensure that we eliminate the s out. So then we differentiate this one again. This is what we have. Limiting x equal to 0. We are already at minus 16. Okay. Minus times minus will be plus. So it's already gone. Times 4. That will be 4 times 4. Then differentiate sine 4x. That will give us 4 cos 4x over. This is equal to 24. This is equal to 24. S will not go. Now, anyway, here, put 0. Anyway, here, put 0. So you put 0 here, because that's 4 times 0, that is 0. Because 0 gives us 1. Or 0 gives us 1. So I'm going to have, like this, 16. Now 16. Because split now. I'm going to write that out. So look how you're going to do it. I'm going to solve it out to check the answer. That you're going to do it. Put 0 here. 0 times 4, that's 0. Because 0, 1. 1 times everything is very easy. That is 16 times 4 over 24. 16 times 4 times 4 over 24. So I'm going to count first. 4 here, 6. I'll do that 4. So 2 here, 2. 2 here, I'm going to 3. 2 times this side was 32 over 3. So I'm going to have 32 over 3 and our final answer. Another will become 32 over 3. You can also change it in this fashion. So that will be the final answer to that. Now let's look at more questions now. Let's solve more questions to see what we're going to have. More questions. Alright, let's look at more questions. We have question 1, 2, 3, 4, 5. To see what we're going to have. Let's see here, remember here, put it, then you can see that variable. Let's look at it here. It's 5, 1 minus 1, that is 0 over 0. So now this and this are not the same thing. Not this one and this 0. Put 0 here, put 0 here, so 1. This one 0. So if you put 0 in the that becomes undefined. So what I'm going to do, I'm going to differentiate both sides using LP method. So what I'm going to differentiate, I'm going to do it with limit. Let's approach 0. And remember, differentiate this, remember, 100 raised per x first, then log e of the base is 100 minus same thing. So it's minus per x, not minus. This is exponential. But 5x is polynomial. So it's 5 is per x. 100 is per x. So it goes 5 is per x. Log of the base is e. Over the s 1. The next thing, anyway, CS, I'm going to place 0 there. Anyway, CS, I'm going to place 0. Let's put 0 on to see what we are going to have. So we have 100 raised to 0 log 100 with e minus 5 raised to 0 log 5 with e. Divided by 1 is to be the same. So the 1 will go, then log was 1 log 100 with e minus it was 1 as well. And it is 0 is 1. Result from 0 log 5 is e. So we have log 100 minus log 5 is exponential. Now, if I want to use base 10, you just like put it and apply like the Fourier conversion. So what I do for me now, just click on this log. You have to be this in. Just put your in 100 minus in 5. Just click it down. So click in 100 minus in 5. Ensure you bracket it to bracket. So that you don't have it will be approximately equal to 2. Let's say you have as your answer. So that is after that. You must want to differentiate. That is the first thing. So now let's look at this. Let's say put 0 here. We will have 0 raised to 3. That is 0. The result becomes 0. So this one looks like the question will solve because in the sense that if there is s in the denominator at all, that's how we become the 0, 0, 0. So what we are going to differentiate with this function until 0 will disappear from the denominator. So let's see what is the differentiation. Let's run x. What is run x? We get 3s, that was 3. We get 3s cubed, that was 3 times. Yes, 3 minus 1, that's 3s squared. So let's rotate again. Rotate this one to the x. Rotate this one to have 6x. Rotate it again because the 3s is the denominator. Rotate this one to special x. Rotate this s to have 6. So you see there's no s in the denominator again. So rotate this to have 3 times s, 3 minus 1, that becomes 3s squared. And rotate one again, 2 times s, 2 minus 1, that becomes 6s. Rotate this one, s will remain the same. differentiate expression x, that's how we remain as expression x. Now, differentiate this one again, differentiate this, we're going to have expression x. Differentiate 6x, we're going to have 6. Now become the answer. Now, since there's no x in the denominator, we don't differentiate again, no, don't put s, anywhere see s equals 0, we have expression 0, 1, 6. When the 0 is 1, that is exponential is power 0, that equals 1, then over 6. Answer. Now let's start this. At s approaches 1. So the first thing, anywhere see s equals 1. 1 is 1 minus 2, minus 1. Yeah, the don't know 0. So the next is 1. 1 squared plus 1 minus 3 all over 1 minus 2. So since the numerator is not giving us 0, it's only differentiating. It is not giving us 0. We have 2 minus 3. 1 squared is 1 plus 1 minus 2 minus 3 over 1 minus 2 minus 1. It's not 0. So we're not going to differentiate now since the numerator is not 0. So we have 2 minus 2 minus 3. That is minus 1 minus 1. That is the answer. So please ensure you know what you are doing here. That's what I'm going to do with 1. Because minus 1 divided by minus 1 equals 1. So I'm just trying to take this out of the sheet very well. So let's try this. Look at this. So we're going to have. So we put 0 in the denominator. So check. 0 is power 2, 0. The denominator is 0. For this case, we're going to differentiate 0. So differentiating is limit x approaches 0. Now, we want to differentiate 100 sine 10x. Since there's no x here, don't leave it. And it's with sine 10x, it's attached to sine 10x, it's leaving the block equals 0. As far as it's attached to this sine 10x, it's still alive. But don't touch it, just leave it with this. Go and differentiate sine 10x slowly. Differentiate sine 10x, what we're going to leave the 100 first. Differentiate sine 10x, we're going to have 10 cos 10x. Remember? Differentiate 10x before, you have 10. Differentiate this side, you have cos, so you use 10x back. Just ignore the 100 first. Then over, differentiating x squared, you have 2x. There's still x in the denominator. And you still put 0 there, that's also the 0. So, the next differentiate again, you have limit x approaches 0. Now look at this. 10 times 100 times 10 give us 1000. So leave that side, don't have to s. Don't leave this side first. That give us 1000. Then differentiating this now. Give this, you're going to have some times 10 times 2 times. Okay, ready 10 times you're going to have 10. Ready side comes, you're going to have minus sine then 10x. Over differentiating 2x, you're going to have 2. You have 2. So, because of space now, I will decide to write the answer out because of space. So that will give us, anyway, CS equals 0. You have 100 times minus 10, that will give us minus 10,000. So you have sine 10 times 0 over 2. That will give us 10 times 0 give us 0. Sine 0 give us 0. 0 multiply everything here. The answer becomes 0, x minus 0, but 2 is 0. So you have the question is 0 actually. Or minus 0 is 0. So that is another that. Now let's try this last question now. And this last question here, which is limiting the function to 1 at s approaches 1. The limit of this function becomes what? Anyway, says 1. From a second, 1 minus 1, 0, there's problem. If you put 1 directly, it doesn't give us 0. So we are going to differentiate. We are going to differentiate this, and this. Relation to this. Now let me show you how to cut the question short. How to cut the question short. Look at it. That's why you should know the techniques of differentiation. Very, very important. Very, very important. Look at what I am doing. Differentiating this. So look at it. Differentiate something like this. The square root of the function of x. Differentiate this one now. Differentiate 2x. The answer is going to be the differentiation of the inside the root divided by 2 times the question. Let's go back. It means differentiate inside the root divided by 2 times the same question. So anything that has square root is not cube root, just square root. Square root. So this square root, now what I'm going to do, differentiate this square root of this function. Differentiate inside the square root. Rotate inside the root, we're going to have rotate 13x, we're going to have 26x. Limit x approaches 1. Rotate 13x, we're going to 2 times 13, 26. 2 minus 1, that's 1, that's 0. Minus rotate this, we're going to have 5. Plus 0. This one, we're going to have 0. Then divide it by, remember we are still rotating this, so we are going to rotate inside the roots and divide it by 2 times the question. So to rotate this one now, not the division though, to rotate this one now, we don't have the rotating inside, we have this, divided by 2 times this 80, that will be the direct rotation of 2 times the square root of 13x squared minus 5x plus 1. So this is the answer to this. Rotate this, we don't have this, which is rotating inside, divided by 2 times this, we give it this. So this rotation one, we have this. Then my rotating 3, that's why I say 0 over rotating x, we have 1, rotating 1, that's why I say 0. So let's see this now, we're going to put 1, and we have it. Let's already 1, now we go. So everything here will just go. Everything will go, because 1 and 2 is over. So the rest out here will be this, that's everything of that there. So whenever you rotate this, you will have rotate this side. You have to divide it by 2 times this. That is exactly that. So if I tell you the rotate the square root of 9x, the answer is going to be, I say why is it equal to this? The rotate this one, you're going to have the rotating inside, you're going to have 9 divided by 2 times. Equals 2. That is the rotate that. Take note of that, it's very, very, very important. So, anyway, says 1 over 46. That's 1. Minus 5 divided by 2 times the square root of 13. 2 times, plus 2 on the left, on this way, 2 times square root of 13 times 1 squared minus 5 times 1 divided by 4, that is plus 1. So what do I get to us? So this one, 26 minus 5. 26 times 1 is 26 minus 5, that gives us 21 divided by, that is 13 times 1 squared, that is 13. That's plus 1, that is 14. 14 minus 5, from 5 times 14 gives us 5. 14 minus 5 gives us 9. Now everything here is going to give you 9. Square root of 9 is 3. 3 times 2 will give us 6. Now let's check what can go. Let's check what can go. 3 can go. 3 here, 7. 3 here, 3 here, 7, 3 here, 2. 7 over 2. Then that will be 7 over 2. Or you just take your calculator, type everything inside, and you use 7 over 2. That becomes, so you just see, so that's how we wrote here. Just any shortcut here, we just dash. So now we'll look at more questions. Look at more questions. We need the function and this approaches infinity. We need the function is 3x squared plus 2x plus 1 divided by 4 plus 3x minus x squared at x approaches infinity. So, okay, let's look at how to do this substitution like this. It's either you rotate both sides until there will not be x in the, let's say, if we have x, if the what we are trying to guide against to ensure that we don't have infinity over infinity. So you keep on rotating both sides until one side loses. If one side loses x, you stop rotating. Then you impute the value of x. Or next thing you do, you divide both sides by the highest power of x in trigonometry. That is comes to. So if you want to do, you just keep on rotating until either the numerator loses x. If you lose x, you stop. You put the value of x to see what you are going to have. You get another side. So one side you lose x, you stop. Put the value of x, and we split it to a have. But if you don't want to do that, that is very long. You can just divide both sides, this side and this side, by the highest power of x in trigonometry. and that will clear up the mystery of infinity over infinity. So let's look at what we're going to have. You see, now let's divide both sides. What we're going to use Tumb'S. Tumb'S is that we should divide both sides by the higher power of s is the denominator. That's Tumb'S. As well as the polynomial, it's a polynomial, divide both sides by the higher power of s in the denominator. What is the higher power of s here? S squared. We're going to divide both sides now by that s squared. We're going to have the limit s approaches infinity. So we're going to divide 3s squared by s squared. And we divide 2x by s squared. And we divide 1 by s squared. Everything we divide 4 by s squared. And we divide 3x by s squared. And we divide this s squared by s squared. And s squared by s squared. So this will cancel this. Cancel 1 s out. And cancel this x. This will cancel this to 1. 11. So the next thing we're going to have the limit x approaches infinity. 3 will be left there, plus 2 by x, plus 1 by s squared, then divided by 4 by s squared, plus 3 by x, minus 1. The next thing, anywhere here, after you have divided both sides by the higher power of s in the denominator, anywhere here, you place infinity, then we will be having 3 plus 2 over infinity, plus 1 over infinity squared, then 4 over infinity squared, plus 3 over infinity, minus 1. So any number that takes this shape, a number over infinity, or infinity squared, or infinity raised power, any power, anything that has infinity denominator from 0. What about infinity divided by a number? Infinity. So any number that has infinity denominator must become infinity. So any number that has infinity denominator must become 0. Anything that has infinity denominator will become 0. So a number divided by infinity, let's say 1 over infinity 0. 20 over infinity 0. Anything divided by infinity give us 0. But it should not be infinity over infinity, it moves. So we will have 3 first. Now this one is over infinity 0. Now over infinity 0. This one is over infinity 0. Now there is infinity, the other is called cube goes 0. That is 0 over infinity. Minus 1. So we have 3 divided by minus 1. That is minus 1. So our minus 3 is our answer. This one goes to minus 1. 3 divided by minus 1. That is these are 0 plus 0 0. Plus minus 1 minus 1. This is also 3 over minus 1 is minus 3. That's what we will have. So by large, listen to this. Because of this, we cannot be solving this in terms of what we are solving, having a little time to solve the question. So we have to use a shortcut. Now, what is the shortcut here? The shortcut is that if you see any question of this nature that approaches infinity, what you do, you check the denominator first. Check for the highest power of s in the denominator. Then check if there is same with the check if both sides have the same power of x. That is first thing. Check if both sides have the same power of x. Now both sides, the highest power of x, same, yes. Highest power of x is 2. Highest power of x is 2, yes. It's correct. Check if both sides have the same highest power of x. Check. Highest power is s squared. Highest power is 2. So that one is beautiful. Now, if both sides don't have the same power of x, I'll show you how to get the answer as well. So, if both sides have the same power of x, what you just do, you just come, you will pick the highest power of x in the denominator, which is s squared. Pick the equation of that highest power of x, which is minus 1. Pick that minus 1. Go to the numerator, pick that same equation of highest power of x, which is 3. The equation of this s squared is minus 1. Pick that minus 1. Pick this equation of this one. So the answer just so much is 3 over minus 1. Now you want minus 1. Let's go to it's very, very important. Very important. But how about this, in which the highest power of x is x5, what one is x3, there's no x5 there. What is going to be the answer to that? What's going to be the answer to that? So the answer to this is, if you discover that the denominator has a higher power than the numerator, For example, now, let's say this one is S cubed, this one is S2. The height of S is 2, the height of this one is 3. Okay, look at this, listen to this. If both sides have the same height of S, pick their coefficients, which is that will become the answer. But if the denominator is higher than the numerator, the power of S in the denominator means the downside. If the downside is having the highest power, that is, the power of X in the downside is higher than the upper side. What do you do? The answer becomes, know that the answer must be 0. Take note. I repeat, if as far as S approach infinity, S was approach infinity for this to work, for this short to work. If the power of the denominator is higher than the numerator, the answer becomes 0. Take note. Take note of that. Because if you divide everything here by S5, you divide it by S5, everything here will have infinity in the denominator. And everything divided by infinity is 0. 0 by anything becomes 0. If we just take note of this, if the power of X in the denominator is higher than the numerator, the answer becomes 0. Now what about, for example, this? If it says that the power of S in the numerator is not higher than the denominator, what becomes the answer? The answer will become either infinity or minus infinity, depending on what you are having. The higher power of S in the denominator is inside this carry. You still work with the denominator. You are still work with the denominator. Don't check the denominator. Check for the higher power of S in the denominator. If the high, just check this one. This one is very, very tricky. Now, just know that if the power of S in the denominator is higher than the numerator, the answer becomes 0. That is very clear. If the numerator is higher than the numerator, the answer becomes infinity. That becomes the answer. That's why it becomes infinity. Take note of that. That's how it becomes infinity. If the power of S in the numerator is higher than the denominator, that's how it becomes infinity. If the denominator is higher than the numerator, the answer becomes 0. But if both sides are the same, the answer becomes the coefficient of this. Whether the coefficient of this outside. Actually, those things you can write it down very, very important. But this one can also be minus infinity. How? It will be minus infinity if the highest power of S in the denominator is negative. For example, what the highest power of S is better than S from 1. And you like this one minus 1 minus X, this one becomes negative infinity. This one is plus, this one becomes positive infinity. So let me write that down. Sorry, let's say limit X, which is infinity, of 7s cubed plus 4s plus 11 all over 3 plus s plus minus 3s squared. Please see, the highest power of s in the denominator is s squared and it's every negative sign. But the numerator is higher than the denominator. So the answer to this one now will be minus infinity. Why? Because the highest power of s in the denominator is having a negative coefficient. But this one is positive, so it becomes positive infinity. But this one will regulate the sign of that infinity. That will regulate the sign of that infinity. Take note. Or we can decide to say, okay, let's divide both sides. I'm trying to check whether it's correct. With that, whether it's correct. Divide this by s squared. Divide this by s squared. We have minus 3 in the denominator. Have negative 3 in the denominator. Then we have what is it called? We have 7x in the numerator. Now 7x is infinity, 7 times infinity becomes infinity. Infinity divided by minus 3 will be minus infinity divided by 2, which is infinity. That will be minus infinity. This one will become like 7 times infinity over minus 3. That will be 7 times infinity will be infinity. Then bring out this minus. Divided by infinity, that will become minus. Anything divided by infinity is infinity. So just take note. This sign here will replace the sign of that infinity. That will become minus. If the highest power of s here is minus, this plus becomes plus as well. Take note of that. Very, very important. So let's say we have like this. Let me check if you want the sound I'm saying. So I have like this 3x plus 2 over x plus 1. What is the answer to this one? To solve. Then now becomes what the highest power of s is x plus 1. So x plus 1, they're the same thing. Equation of x is 1. So that becomes 1. Equation of result is 3 over 1. That's the answer. Just going to the activities now. 3 ways to solve this question. If both sides are the same, pick the coefficient of this one, pick the coefficient of this one, that becomes the answer. Pick the coefficient of the highest power of x denominator. If the same thing as that denominator, don't pick the differentiation, that becomes the answer. When if the denominator is higher than the numerator, that becomes 0. When the numerator is higher than the denominator, becomes infinity. When the highest power of the x denominator is negative, infinity will carry the negative sign. So that's why this one becomes what? Let me check. When the highest power of x cubed as the highest power of x. You see the same thing as the numerator? Yes, it's the same. So what I'm going to do here? What is going on with this one? What is one, but we will not put it. But if this one, we will not write it there. So just come, pick the coefficient of the highest power of x, which is x. See the same thing. When your answer is 5, you have 5. When your answer is 1, you have 1. That's the answer for that. It's not that hard. You have to be very vigilant. Very vigilant in those questions. So let's write one more. Limit x, which is infinity, of 7x 5 plus 6x plus 11 over 3x plus 5 plus s squared plus 9. So the other term becomes, write it down every single unit. What we call the other class? That's how we call 7 over t. And become the answer. You see equal to why? Because both sides have the same power of x. The highest power here and the highest power here is the same. The highest here, highest is the same. That's how we become coefficient of the highest here, the other coefficient of the highest here. But both of them have the same highest power. But this one is having higher power than this. That's how we become 0. This is more than this, and that's going to be infinity. But if this one is more than this, and the higher power of x here is negative, we need to carry the negative sign. So take note of that. So this is how we run through this. If there is a question under this limit, we'll still let you guys know. And if you have any question, you are free to drop it in our comment section. Thank you. God bless you. Yeah, thank you.